All right, my name is David Tessar, Senior Technical Evangelist here at Microsoft, and we are at Ignite. And we also happen to have this as Edge Show number 145. We're joined by a couple very special guests here, Brian Harry and Donovan Brown. Welcome.
Thank you.
Thank you. For folks who may not know who you are already, can you maybe just tell us a little bit about yourself?
Sure, absolutely. Yeah. My name is Brian Harry, and I'm in charge of Visual Studio Online, Team Foundation Server, and Application Insights in the Microsoft Developer Division.
Okay.
My name is Donovan Brown, and I am a new addition to Brian's org, and I'm a Senior Program Manager for pretty much all things DevOps.
Okay, it's good stuff. We've got a lot of DevOps action right here.
It's an exciting time to be in DevOps, so I'm really picked a perfect time to join.
Most definitely. So what I'd like to do is kind of walk through, both of you have a lot of great experiences working in running, with the Visual Studio and TFS teams, with this DevOps practice, and you, in your life up until very recently, you've been working a lot with customers. So, at Microsoft, of course, we realize DevOps is about people, and so DevOps and the business all working together. So what I'd love to know is just kind of stories about, for instance, how does the VSO team have some good successes in people working together within the organization?
Yeah, we've been through, I've kind of been on both sides of the DevOps world, or sort of pre-DevOps and post-DevOps. We've been operating Team Foundation Server internally at Microsoft for 10, 11 years. And for the first 7 or 8 years, we operated in a fairly traditional ops model where, I managed the dev team, and then central IT operated was the operations team. And I learned a heck of a lot doing that, because what I learned is that the two organizations, both very well intentioned with trying to do the right thing for their customers, yet had very different goals. Mm-hmm. The ops team's goal was to keep the system up. And the number one rule in ops is, what's the number one cause of system instability?
Changes.
Changes. Don't change anything. Because if you don't change anything, the system keeps running.
Yeah.
It doesn't fly with the dev team.
No.
Because the dev team views their role is to deliver new value to customers, and in this case, internal customers. And that just creates this terrible dynamic between dev and ops that they don't get along. It creates distrust and misalignment, lots of problems. So I lived in that world for years, and as we went to cloud, we transitioned in that sort of technology and cultural transition. We moved to a DevOps model, and we combined the operations team and the development team into a single organization. It's not at the CIO level where it's combined. It's under me, and in fact, even a layer below me, it's combined. And much better alignment in terms of accountability, responsibility for sort of the end result, that is just made the process a ton better. And now the two sides view each other as assets. Like the dev team couldn't live without the service engineering team, and vice versa. It's a great relationship.
Okay, very, very cool. Yeah.
For sure.
Yeah.
And it's true, not even inside Microsoft, it's clearly true, but our customers are realizing that exact same revelation, to where if we can break down that wall, that barrier, and stop pointing fingers at who broke it, and actually work together to get more value to our customers quicker, it's just a better world for everyone. Because I think the goal of DevOps is to really produce the best product we can for our customers. That's really the end goal. And we do all these other things, like automation and breaking down barriers and process and people, all to do that one thing. Let's deliver the best experience we can for our users, and we're all experiencing that.
That's right, and that experience is some combination of features, capabilities, value, and stability. Both are important.
Absolutely.
You can't take either one out of the picture.
Yeah, I mean, just because the button's there, if I click it, it crashes and the whole system goes down, that doesn't help us.
That's right.
It needs to be everything.
Yep.
So I think, still a lot of organizations, and especially ops folks, maybe you still think this is not real, that you can have more change and more stability at the same time. I mean, is there proof points there? I mean,
I think you've got to be careful. First of all, there's no system in the world that has no instability. Even if you don't change anything, stuff breaks sometimes.
Yeah.
So every system has instability, but you always strive to minimize it, to drive it out of the system. But one of the things that I think DevOps recognizes is that you can spend all your energy trying to drive out sort of the last possible cause of instability in the system, or you can spend half that much energy getting really good at fixing the problems when they occur. Good telemetry and monitoring to understand what's happening in the application, early warning signs, good processes for getting the technical people engaged, the devs, the testers engaged immediately when there's a problem, getting it fixed. And instead of, I think you look at some of the ops issues. Like, again, in the old ops world, when there was an issue, what would you do? You reboot the machine. Like, that's the number one thing. And what does that guarantee? It guarantees it's going to happen again. Because
true. You didn't fix anything.
You didn't fix anything. All you did was get the system back up.
Yep.
And sort of, in the DevOps world, you focus on a huge focus on root cause, a huge focus on rapid reaction, and then getting the fix, redeploying, or making whatever, it's an infrastructure change, a code change, a configuration change that sort of permanently fixes that problem, and you sort of get all these problems behind you and sort of always improving the stability of the system.
Yeah, I also think it makes me also think about a lot of the other like DevOps practices that are tied into there. So, continuous integration, continuous deployment, release management, infrastructure as code, all these things having a very quick flow, because that dynamic to create a fix is much different when you have something like testing in production where you flip a bit or feature flags and you turn on things and you can very quickly in a snap turn it all off, right? And at least you can figure out root cause while you get your people back up and running.
For sure.
Yeah,
because there's 3 pillars to that DevOps story, right? There's I call it the 3 Ps. It's the people, the process, and the products, right? You kind of need all 3 of them to come into alignment to really get what you need. You first have to have the people who are going to facilitate the process for you, and you have to have that desire to change your culture, because a lot of us are so skeptical about the other side, and we want to hold, this is mine and I don't want you to touch it, but we kind of have to trust, so we have to have the people in the process. And then the products are what give us that trust, because if a human has to go touch that, I'm nervous. But if I have this automated process that has done it hundreds and thousands of times and does it perfectly every time, then I start to have less worry about that pipeline being faster and more efficient.
Yeah, being on the same page with the process and tools definitely helps. What about culture? Like, what are some ways? I'm sure, like, you've seen a huge culture shift, in the organization. I mean, what are some dynamics that you see happening now, in terms of helping each other out?
I think there's a bunch of pieces to the culture, and I don't think I can enumerate them all. I don't remember them all, but as I think about some of the changes that we've gone through, one of them certainly is this culture of dev accountability. Devs are accountability not just for the features they produce, but for the stability of the service. Sure. And I think about some of the changes we go through. There was a period where every system has some kind of monitors. You use System Center, or you use some other telemetry system that's monitoring perf counters and various things and firing alerts. And systems, most systems fire a lot of alerts, and somebody's job is to kind of go look at all those alerts and try to figure out which ones matter and which ones don't matter. And we went through a period where we were getting where we missed some serious production issues where the alert actually had fired, but the person monitoring the alerts dismissed it because it looked like one that was a noisy alert that he'd seen before, and he ignored it, and we had a production incident because the alert wasn't sort of paid attention to. There are kind of 2 problems there. One is there's just too many alerts. Like, if an alert is firing and it isn't actually indicating a real problem that somebody should do something about, that's a bug and should be treated like a product bug. So, sort of culturally, back to your sort of cultural question, the devs have to think of like monitoring and system health and stability as part of the product, as part of the code, as part of what they're responsible for. And when we did that, we made this big effort to get the devs to go in and clean all that up. And then we took away that front-end alert person and said, you know what, the alerts just go to the devs. When there's alert, we do actually have someone who watches them to sort of engage the right people, but the alerts go to the devs, and the devs go then investigate, I need to look at that. So sort of dev accountability, I guess that's the big thing I'll highlight.
Yeah, well, and then also, I mean, I think you gave that's a good example of the dev having a culture shock of like, I'm supporting this thing in production, I'm getting alerts, I'm getting woken up potentially on certain things, like right away in some cases. There's also the flip side too, on the ops side, right? You know, ops guys who are maybe going through a 50, 100-page deployment doc, that's probably not going to really work so much, right, in a new world.
That's terrible,
So
Yeah, I'm a developer by trade, and I know if I'm going to be the one waking up in the middle of the night because of bad code, I'm probably going to be a little bit more careful in what I push into production, right? It's a consequence for my action, right? And if you don't have to pay any of them, then you're just going to keep doing whatever feels good. But it doesn't feel good to be waking up in the middle of the night, and it's kind of neat to where the responsibility is getting pushed back where it belongs in some instances as well.
Well,
yeah, I think you know, sort of back to some of the cultural things on the ops side is, and it took me a long time to drive this through some of my service engineers' heads, and because it's counterintuitive. Traditionally in ops, the mental model is live site, like getting the site back up is the #1 most important thing, right? Everything, nothing else matters. So it's all about how quickly you can get the site back up. And the cultural thing I had to drive into the team is, while absolutely that's important, it is not, in fact, the #1 most important thing. The #1 most important thing is making sure I've captured the information that I need to root cause this so that it never happens again, right? Yep. So we did a bunch of work in tooling, we did a bunch of work in training, we did a bunch of work with that ops team to make sure that they are capable and knowledgeable on how to make sure we get crash dumps, we get memory dumps, we get, you know, all the telemetry and everything before we reclaim that system or do whatever we have to mitigate the issue. And so that is this very delicate balance, because you've got users who are in pain. Your service is down, your business is losing money, and at the same, so there's this, like I said, there's this very tempting, just reboot it and it'll probably fix it. But all that does is guarantee it's going to happen again. So you've got to get there, and that was a big cultural change for the operations guys.
Yeah, just rebooting the machine is like tampering with a crime scene. You've just contaminated everything.
That's right.
We'll never be able to identify that again. And those rare ones where it takes running for months or weeks before it shows up, and now we have to wait weeks again before this happens again. It's so valuable to capture that. Yeah. And of course, we have better tooling that can help us capture that as well.
Yeah,
right?
IntelliTrace is a nice tool.
And App Insights is actually going a long way towards that as well.
Yep.
Absolutely.
And what I hear current of is also ops helping with automation in that life cycle and kind of up-leveling some of the things that ops is doing, and, you know, learning, maybe they have more time now to learn about the architecture of the application, so they're also more effective in troubleshooting and knowing the architecture of where this thing lives, like, you know, being able to troubleshoot disk I/O and things that they're more up their alley, they've been doing for a long time that most devs probably haven't been you know, doing those kinds of things, right? Sure. So,
yeah, we certainly went through a significant journey, you know, in sort of maturing along that lines from, you know, a pretty manual deployment process. You know, almost everybody starts there. You build the app, and nobody thinks hard about how you're going to get it deployed and how you're going to update it on a regular basis. And you know, we were talking earlier about this notion of technical debt, and technical debt you often think about on the dev side of things, but there's an ops side view of technical debt. Technical debt is sort of anything that sort of slows you down. It's sort of inefficient processes or practices that make it difficult for you to make forward progress. And deployment is one of the classic examples of technical debt, because what happens is you've got a process to deploy this app, and then something changes, and you need to tweak it. You need to do something a little different. So what do? You just go in and you tweak it, and it happens the next time and the next time, and over time you end up with all these sort of special tweaks that are either, you know, sort of tribal knowledge that are in somebody's head, or if you're really lucky, they're written down in a deployment guide, which just gets, you know, thicker and thicker by the by the month. And so one of like the big rules of DevOps is automate it all, right? That's sort of the config as code. The entire deployment should be automated. So we went through that journey from the 300-step deployment process to the 3-step deployment process that says, run this script, update that dashboard, and sort of very, very simple. And kind of the next step in that journey was introducing release management. And we use our release management product, and we actually took ops completely out of deployment. So ops now, the devs do deployment. The config is code, it's all checked in. Ops code reviews it, ops participates in the understanding and helping make sure we've got a deployable app. But the actual decision to deploy is done by the dev team. They just go into Release Manager and say, initiate this release, and then it stages out through the environments, runs load tests, runs validation tests. There are places in it where ops can do approvals and on key transitions, but that used to be like an entirely ops orchestrated process. Now the engineering team owns it.
Yeah,
perfect.
Frees up times from the ops guys
That's
to
right.
look at and inspect. They know the infrastructure is code. They can say, well,
Yeah.
I see that dev guy, you checked in this change that we have an issue with fault tolerance or high availability in that infrastructure that you're trying to deploy to.
Sure.
So they can provide that kind of insight. Yeah.
Yeah, I mean, that time we freed up, this isn't like we, reduced the ops team by half. Like there were tons of other incredibly high priority things that we needed to be doing. So an example of one of the things we started doing once we freed them up from that, I mean, we deploy every 3 weeks. And so that's like every 3 weeks you're going through this deployment process. So it's a lot of effort. We sort of took that, freed up that time, and one of the examples of something that we started doing was, it's called red-blue testing, which is basically red team, blue team. The red team's job is to try to break into the service. The blue team's job is to try to defend against someone breaking into the service. And we now run sort of regular red team, blue team drills, and it's actually a shared activity between the dev and ops teams. Basically, we have both SEs and software engineers on both red and blue, and they try to hack each other. And
That's cool.
I mean, it's incredibly important. We found some really good security gaps that way. If you don't do that, I guarantee someone else will do it for you.
Yeah. Well, and certainly if you have your ops and/or dev teams under a pile of technical debt, I don't think they're going to probably prioritize red team, blue team exercise until they probably get hacked potentially.
That's
right.
But that's cool. That's a cool story.
Right.
What are some other ways? You mentioned automation, and that's a huge one across a lot of different ways. What are some ways that people can maybe help reduce their technical debt within their organization, for dev and ops?
No, I think Brian pointed it out. It's making sure that you solve the problem and don't just fix it and don't tell anyone that you fixed it, because that lingers and you don't have that security that comes with it. I even think things like unit tests can actually stop technical debt.
Yeah, it's a very important part.
Because I tell people they play ping pong with themselves all the time. I fixed a bug, and I was a panic, so I fixed it, and I didn't write any unit tests, and I threw it over the fence, and it worked. And then a month later, I get this other bug, and I fix it, and not realize that by fixing this, I broke this other one again. But I don't know that they're related, because I have no security net that's going to tell me that, hey, Donovan, by fixing this, you broke this. But if I stop just for a moment, like you suggested, and I write a unit test that exploits the bug before I fix it, then I fix it, I always know that bug will never show up again without me knowing about it. So a month later, when I get that other bug and I change it and I run my unit test and it fails, I was like, holy macro, I never realized these were related. And had I not written that unit test, I'd be playing ping pong for the end of time.
Yeah.
Right? So it's really important to stop and get that root cause analysis and have a way to automatically tell me, am I doing well or not? So I'm a huge, huge fan of unit testing and tell every company, stop the bleeding. I don't intend you to stop what you're doing and go write unit tests for hundreds of thousands of lines of code that are working, but the next bug you get, the very next one, do not fix it unless you have an automated way of exploiting that bug for me. And then just build that safety net that way.
Yeah, I agree. Unit testing is an incredibly important part of reducing and eliminating technical debt and driving quality early into the process. The earlier you can drive the quality, the better off you are. Now, I think there's sort of the other extreme. There's a spectrum of testing, and unit testing is usually kind of the very beginning.
For sure.
The other end of the spectrum is called test in production, and that is where you actually monitor the behavior of the application in production. You run sometimes synthetic tests against it. You monitor real user use to see what they're doing, watch their performance, watch their watch any exceptions, any sort of log entries that are happening, and sort of react and fix that very proactively. I think those two are very important, both incredibly important bookends in your sort of testing process. I think you have to do both.
And it's interesting because it keeps taking us back to application insights, right? There's just this really cool product that just kind of underlines a lot of what we're talking about because it can do those synthetic transactions for you in production and let you know if they're failing.
Well, and the Azure websites. I mean, the deployment slots, testing and production, done. Like add a slot and then add a 0.5% of traffic to that Azure website. Wow, now you have testing and production. Like it's super easy, and if production goes down, it's like seconds and you're back to what you were before.
Absolutely,
it's pretty amazing. I'd love to switch to kind of measurement a little bit.
Sure.
And like how do you, we've talked a lot about the people and some of these things. How do we have like metrics and goals around DevOps?
I think one of the coarsest grain and the easiest one is how often do you deploy today? Obviously, you weren't deploying VSO every 3 weeks when we started this.
Yeah, it's about every 6 months.
Exactly. So that was the easiest metric, right? You don't have to go data mining for it. Just how often are we able to deliver today than we were a couple months ago or a couple weeks ago before we implemented this process? And you go from 6 months to every 3 weeks. That's clearly we're doing a lot better than we were before. But then you can obviously go much deeper than that and start looking at more fine-grained analysis of some of the metrics to determine how you're doing. Because just because we're deploying more often doesn't mean the quality of the code's any better, right? So there's other places we can go and look for.
That's right.
Too.
Yeah, I have a monthly, what we call an MSR, monthly service review, which is a joint review between the engineering team and the service engineering team, where we look at service health. So we look at availability. We review all of the major incidents that happen, root cause. Time to detect, whether it was a manual or automated detection, because you want to drive almost all of your incident detection to automated. Time to mitigate, time to resolve, sort of all the metrics. We look at adoption metrics to understand how many users are coming onto the system, how many are leaving the system, sort of judge customer satisfaction. We look at usage, how deeply are they using the product, what areas are they using. We look at financial metrics to understand what's the cost. Like, is the cost going up? How are the changes that we're making to the software affecting the cost? We look at the revenue side of things to make sure that there's no business here and we're just a big pit of money that we're pouring in. It's an incredibly valuable focusing process for the team to get everybody to kind of look at the same set of things. And it's we have a slide deck template that we use. It's like maybe 20 or 30 slides that we go through every month just to understand how is the whole view of the service going, from health to adoption to usage to cost, etc.
Very cool. Because obviously the VSO team, you've been doing this for quite a while to get to a 20 to 30 page deck with all these metrics.
Sure. Yeah.
How can somebody maybe who's getting started help start to get this data using maybe products and tools and services that Microsoft could provide?
Yeah, I think there's a number of them. So Application Insights is again a great example, provides an awful lot of the live site data that you might want to look at. I think we, for example, use TFS, or we actually use VS Online as our work item store. So all of our incident stuff comes out of that. Every time there's an incident, in fact, we have a customized work item type called incident, live site incident, and it tracks in that work item everything that happened, all of the tasks or user stories that were generated by that live site incident, and all these metrics that I talked about are in there. So you can just generate these reports off of the data that we track inside VS Online. The other one on sort of the dev or engineering side of things that's interesting to look at is there's this thing called Sonar Cubed, which is a pretty popular tool for tracking technical debt. So they look at things like code analysis to understand sort of where your coding practices are not kind of where they ought to be, code coverage to look at how your tests are doing, etc. So a whole bunch of metrics and nice graphing and dashboard and trending and build over build diffing and stuff like that to help you understand how you're doing as an organization. It's another good tool.
Okay. And what about release management stuff? I mean, do we get data from that as well?
Yeah, absolutely, yeah. The release management tool is able to produce sort of information on sort of all our environments, what versions are deployed to those environments, what the sort of metrics in each of those environments are, the time to release, time to move things through that environment, all of that kind of stuff. Yeah, absolutely.
Okay. Okay. Cool. How has would you say that the shared metric approach changed your team and how things are done? In terms of kind of that metrics guiding goals aspect.
Yeah, I think the simplest way to say it is, I think we really have a team where I believe engineering and operations work hand in hand. Like, they really do feel like they have a common goal. It's not one against the other. It's not a trade-off of this for that. The service engineering team has embraced change as a part of their life, and that we don't have a product without it, and it's an incredibly important. Their job is to support as much change as they can, as they can possibly enable, and the dev team understands that their job is to keep the service as stable as they can possibly keep it, and it really is hand in hand. We act and behave as one team. We do everything together, and that's, I think, the sum of all of the things we've done, whether it's metrics or processes or the way we define responsibilities, like the red-blue exercise. We put, we have dev and ops on both, and it's very much a shared view of what we're trying to do.
And that's successful whenever you're running a software project that I found, right? I really need my team to be a team and not say, well, man, Donovan messed up, that's why that happened. Because when the end user gets a crash, they don't know which developer caused that. The entire team looks bad, right? So we either succeed or we fail as a unit, right? Use whatever metrics you want, but the app has to be running, because I'm not going to blame just Brian or just Donovan when the user can't use the app. We fail as a team, we succeed as a team, and let's measure it however we need to.
Yeah. And then, you got to be careful. I'm a big fan of the 5 whys. Often, if you have a problem, you'll find that the problem manifests as something in production, and if you look very shallowly at the why of that thing happening, you can point your finger easily at someone in the SE team that didn't do something right, or something that was configured wrong in the production environment or whatever. But you kind of got to keep asking, well, why was that? And you'll often get back to, well, because the dev didn't automate that step of the deployment properly, or whatever. So you always got to kind of track it back to what was the real root cause that caused this. Maybe the real root cause is we didn't train people, we didn't document properly, we didn't automate properly. Like, those are often the real underlying things. And when you sort of stop early, it very quickly turns into finger pointing. Oh, it was that guy over there, or that that person over there. The team has got to not be afraid to trace it back to what was the real root cause and fix that real root cause.
Cool. Well, I'd love to switch gears here to a little bit of the future and kind of Microsoft and DevOps and kind of where are we headed. So I know there's just a sea of stuff that's just come out from from Build and Ignite here. So maybe both of you can talk a little bit about that and maybe Microsoft investments and open source investments that we're making to try and help overall.
Sure. No, go ahead.
No, you're going to be driving it.
Okay, great. So that's interesting. So it's just going to be my responsibility. One of the reasons that I'm so excited to be a part of this is because if you start to try to develop a enterprise-grade DevOps pipeline, you can run into something what I like to call vendor explosion. There's so many vendors that you think you have to go engage. But spoiler alert, you only have to engage one, right? We are the only vendor on the planet that actually has all the tools you need to take you from tracking the idea to monitoring in production. So I'm really excited because we have everything that you need, from work item tracking, application insights, release management, build, you name it, from one end to the other. So what I'm really excited about coming on to is making sure that they all stitch together effortlessly for us, right? So we have the pieces, do they really stick together properly, and do they all stand out on their own to be the best in breed? So that's what I'm really hoping to come to the team and make sure
sense.
I drive forward.
And one thing I'll add to that, and we'll make sure that it works for all the platforms that you have.
And it does, and it's interesting because my demo on Thursday, I'm developing a Java application inside of Eclipse that checks into TFS, but then deploys using release management to a Linux machine, right? So it's a new age for Microsoft to where it doesn't matter what technology you're developing in or what platform you're targeting, we have you covered, right?
Because
all those tools I mentioned,
iOS
absolutely, all those tools I mentioned work with regardless of what language you're developing in.
That's right. Yep.
Fantastic.
Yeah. So I think that's a wrap, and thank you guys so much for
My pleasure.
coming on the show.
All right, thank you.
And look forward to more things coming from Microsoft and DevOps.
It's going to be an exciting world, for sure.
Great talking with you. Thank you.
Pleasure.